Thank you for inviting me here. It's a real pleasure to speak in front of you guys. So I will say a few words about Slovenian Internet Exchange at the beginning, then we will go into more technical stuff. So I hope you like BGP, ARP, prefix lists. I hope you are technicians, you will find this stuff interesting. Okay? So first about me, I'm one of those who still drove those cars, you know, Stojadin. So I'm from that generation, and but I don't have one anymore, just a model. So this is the only one left. But I'm happy to climb the highest mountain in Slovenia. It's called Triglav. So every Slovenian should do that. But otherwise, I'm a network engineer. I work for Slovenian Academic Research Network. And as you will see, I will show you, we also run Slovenian Internet Exchange. And this is our agenda for today. A little bit about Slovenian Internet Exchange, and then the ugly stuff, you know, the practical examples. So if I'm going too deep in some cases, please throw something to me or just wave. Okay? It's about Slovenian Internet Exchange. You all know Slovenia has tradition in Laško pivo, but not only Laško pivo, we also operate SIX for almost 20 years now, and since 1994. And at that time, actually, in Germany, there was German Internet Exchange and Amsterdam X, and Links was there at the time, maybe one year later. So we started really early. So we will be celebrating 20 years next year. So we are proud of that. And a little bit of history, we started in 1994. Obviously, you need 2 members to build an Internet Exchange. Okay, so at that time, 2 guys decided that they should put the cable between their routers and start talking BGP with each other, and that's how it started at the time. 2 members, and then afterwards, after that, more members came, because at that time, you still know what ATM is, or frame relay? Yeah. At that time, it was really difficult to buy lease lines. They were so expensive, so that was the need for a local internet exchange in Ljubljana. And it was difficult to get fiber from telecom, hard to get. So, and interestingly, it was much cheaper to get a lease line to US than to Austria or to, I don't know, from Ljubljana to Maribor. Crazy, crazy era. But after a while, after 4 years, also Big Telecom Slovenia joined the club. But that kind of, the growth stopped at that time because they didn't allow the switch, but this internet exchange was built, was in the telecom premises. And they didn't allow other operators to come in. Yeah. This is a big problem. So we decided to go to another location, and we set up another location in pure neutral environment, like an institute in Ljubljana, and we interconnect both locations. And after a while, also Telecom joined this second location. And after that, it was much easier for all. So this is a little bit of history, maybe interesting for you. First IPv6 peering was done in 2006. Okay, it was just a BGP session and maybe some pings, you know, nothing more. But okay, it happened then. And since then, we are promoting IPv6 at 6 as much as we can. So these are the forbidden graphs. I named them forbidden because they appear in every IXP presentation, and people are kind of don't want to see them anymore. But okay, just for your reference, we have 26 members now. More than half then have 10G ports. Yeah. So, and most of them have IPv6. Here is the number of members during the years. So you will see these dark ages here. You know, the ATM and this stuff. And Telecom didn't want to sell dark fiber, and then it goes up. Interesting to say that nowadays we see more content providers coming in, like local televisions, like some companies, you know, not ISPs, just the content providers are coming in, small companies. So that's what we see now. What is Internet Exchange, actually? Basically, it is this, yeah. Kind of cross-connect with two members, and you have one additional port for other members. But it is not only that. Today, it's much more. We are using Cisco 4500 series, 4500X series switches. We are layer 2, so we switch at Ethernet. We are now present at 2 locations and nationwide. So we have one member from Austria, but that's all. So, and we use root servers. I will show you, I will tell you more about root servers later, and then Harald will show you good examples how they use root servers, maybe even better. So today, Harald, today, yeah, nice. So today we are like this. If you plan for an Internet exchange, there are several things that you have to think of. You have to choose the proper location. With many other fiber providers can come in with their own fiber. So this is the very important thing, to choose a proper location. And of course, power supplies, grounding, cooling system, physical security, all that stuff. So let me talk about a few minutes just about this, and then we'll go into more hardware stuff, okay? So this is very important. People often forget to document. Good and accurate documentation, this is really important. And other things like monitoring, alarming, ticketing systems, you know, mailing list, portal. This is all the things you will need, not only the switch. So it is quite kind of more complicated than that. Okay, contracts. I don't know about SOCs, but in Slovenia we don't have any contracts at this time. We don't have any SLAs. We don't charge. In Serbia, it's probably much different. At the time, we don't charge because we are funded by governmental. We are funded by taxpayers, actually. So everybody in Slovenia pays for that. If you run an Internet exchange, it is a good idea to also plan for kind of a small data center or colocation. Good business opportunity for you. So if you plan for that, then you need power, obviously. So you have to allocate, you have to calculate how much power you will need, how much power per rack, how this power has to be redundant. You have, it's good idea to have diesel generator, like in power outages, or maybe even 2 diesels out there. And yeah, you pay. This is maybe interesting. That typically the load, when people will drop in, will increase by number of 2 every 5 years or so. Something like приближно. And of course, there is cooling. No? So full redundant cooling system. We decided to have 2 aisles, so we have one warm between the racks. You know, we have one warm area and cold area. And it is very important that you don't allow the airflow from the warm area to cold area. So you can improvise. You can put some panels, whatever. You don't need to buy very expensive things to do that, but just separate the air. So the cooling system will be efficient. Of course, if everything else fails, like this summer, these fancy chillers we have on the top of the roof in our data center failed because they are not designed for a tropical environment like Ljubljana is, you know, tropical environment. And so we have to chill them down with water. This is like Gardena, you know, sprinkling all, because they just stopped. You know, I mean, they were too warm at the summer, and they just stopped, and everything went down. And one stopped, the other stopped. So this was the only way to go to the roof and chill them down with water, like gardening. Fire, it can happen. Be prepared. I think, I mean, be prepared, be prepared to happen, but I don't know. Or hopefully it would never happen. Okay, so you think about sensors, how to censor the fire. These aspiration sensors are very sensitive, and they can be used for early warnings. But these optical ones are much cheaper. So it is a good idea to combine them both. You know, to have some early warning sensors, and then more these less sensitive and cheaper ones, to combine them. And of course, when this actually, if it happens, you have to extinguish the fire. Displacement of air is very environmentally friendly, but unfortunately, when this extinguishing system goes on, it's very noisy. So it's like to replace all the air from the data center, pulls it out, and it's very, very noisy. So they say that it can harm hard disks also. Recent results show that actually the hard drives can be damaged by this. So I would suggest we are using something like that. I don't know if this information is correct, but we are using some of these chemical fire extinguishers. They are expensive. If this bomb, it's a huge bomb. If this bomb goes off, you are lost 2,000 euro or so in a few seconds. So these are kind of you don't wish them to go off. So about fire protection. And I will now go into more details about how to configure, how to address the internet exchange, etc. If there are any questions or I'm not very clear, please tell me, because you will get the slides and you can read them afterwards, but if something is really strange, please tell me, okay? So first, addressing. Addressing, then port configurations at an internet exchange and some guidelines for members, and goodies like root servers, like peering DB, this stuff. Okay, addressing. I will show you an example of addressing schema at Slovenian Internet Exchange. So we are rather small, so we need, for IPv4, we have 1/24. And I know in Serbia, probably this is not enough.
We have two.
You have 23.
We have two 24s.
Two 24s. So because we have two locations, we decided to separate the IP addresses per location. And we were numbering one location from 2 to 99. You will see one is obviously for some reason left, because root server has one. and the other location from 102 to 199. Why didn't we split this to two subnets? Any idea?
Because you're not routing between them, for one thing.
It's a flat network, yeah. If you split this to two subnets, somebody clever enough will think that there are actually two subnets there. And they will type the wrong mask. And it actually happened. So it is a good idea to prevent this stupidity to happen, not to allow members to use the line. For IPv6, we decided to put an AS number at the end of the IPv6 address. The lower bits. For us, it's important to use the lower bits because you guys who know IPv6, you know probably there is a solicited node multicast address, which is formed of the last 24 bits. And if you use AS number at the end, every address has its own solicited node multicast address. No addresses are part of the same multicast group. So this is just a proposal. I'm not suggesting anything here. You might do the other, maybe numbering 1, 2, 3, or whatever. How about SOCs? How do you use what's
Actually, we have to ask Nenad.
We use practically use the same address as we use in IPv4.
So you
last 8 bits.
Yeah. So if you use 17 here, you put 17 here.
Yes.
Okay. Good.
We don't use AS number because some of our customers have redundant links, so they have two addresses. And
Yeah.
in that case, your solution is not accepted.
Yeah, we handle this with this, you know. So we use, if they have only one router, we type 0 here, otherwise we use 1, 2, and we use L here for location 1 and 2. So we kind of, maybe it's complicated, maybe not. Maybe it's for you to decide. For access ports, what do you need? Here is an example. Do you know, you guys know Cisco configurations? Most of you? What is important here? This one, port security. So you drop the port, you don't want members to change their MAC addresses. So you have to have one single router there. So if they change the router or MAC address or whatever, they should tell you. If something goes wrong, they should drop the port. And okay, you should take care about broadcasts, okay? And spanning tree. Do not disable spanning tree because somebody will make a loop. Sooner or later, some wise guy will make a loop. And okay, it's a good idea to have some net flow. So it depends on the technology. This is the Cisco-like, they're using NetFlow v9 to export data. And here is an example how you configure the exporter. So you export the number of packets between the two MAC addresses. So you have kind of statistics. This is a good idea to have. Just for your information. Anything to ask about that? I mean, any questions? Please just interrupt me. No, okay. So if you have more locations, you probably have some links between them. And it is very good idea to have more than one link between them. Yeah? And it's very good idea to have these two links on a separate path. One from the other side of Belgrade and the other, you know. I'm talking all the things you know, probably, but...
And that's what we do.
Yeah. And
what kind of protection protocol do you use?
For them?
For bonding two links together?
We use, in our case, we use LSCP. Cisco called that stuff 80 channel. So we actually make one link of it. It looks like one Ethernet link, but it's used to separate paths. And I would suggest you to set the MTU, the maximum transmit unit, to the maximum size possible. You never know. Okay, you might not use the MTU that big on the switch, but why not set it to the maximum? Because if you set it later, you probably have to reload the switch or something. So at the start, at the beginning, you set it to the maximum. Load balancing or kind of hashing algorithm, some switches, keep in mind, do load balancing based on MAC addresses, not source or destination IP addresses, but based on MAC addresses. So traffic between the two pair of MAC addresses will always go to the same link, which is not, maybe in some cases, not a good idea to share both links. So you might configure the other hashing algorithm, like using source and IP, source and destination address for hashing. Okay? That's about it. Now, it's not always the good things, there are the bad things. And I will spend a few minutes now talking about the bad things. Proxy ARP being one of them, redirects, and I will move to some examples and to BGP, which is more interesting, like a policy tool. Okay, about proxy ARP. Do I have to explain what ARP is? And sorry, those IPv6 gurus that are here present, this is only for IPv4. Sorry. So Jan. ARP is needed for a system to learn which hardware address is used for certain IP address. Okay? So you have an internet and you have to find the MAC address for a certain system. So that's why ARP is used. And if you have routers like with proxy and ARP enabled, bad things could happen. There were two incidents, at least this is about 2 years ago, or please, Harald, do you know about this? Maybe you can help me here. About 2 years ago or something, yeah. They were reported in Amsterdam Internet Exchange and in German Internet Exchange. For example, I will show you an example. You have a customer that has a brand new router, and it connects this router to Internet Exchange. They misconfigured, or they did not configure properly, the IP address on the port. So they don't have any IP address from the peering client on the port. They have a default route, and they have Proxy ARP. So what can happen? Other members who send ARP requests to this common Ethernet, these guys with this brand new router can reply for them, please send these packets to me. And all the Internet Exchange can go down. So that's why some of those, like in Amsterdam, they always check for Proxy ARP, and they shut down the port of a member if they discover that they have this feature enabled. Unfortunately, this is enabled by default on Cisco routers, at least on some of them.
Last question. This default route is pointing to a device or to an IP address on the other side?
To some, but it doesn't matter. It
It
could be pointing anywhere. The other situation might be that they have some BGP with others somewhere, and they receive a more specific subnet for this peering line. For example, you have /23, and they receive from somebody, I don't know, from Afghanistan /25 for that. And they always, because it's more specific, and with Proxy ARP, they can ruin part of the Internet Exchange.
You'll lose if you
Part of
receive
it.
more specific.
Yeah.
Your BGP sessions to all the other peers in that more specific will go down because they're not.
No, this
they're
is
not
directly
like-
connected,
yeah.
so they will still go
Yeah.
out. Yeah.
No, they'll go down because the route is no longer directly connected.
Also this.
Yeah.
So Proxy ARP,
I've seen that.
to be short, disable Proxy ARP. Okay. So next thing, ARP is very sensitive. Everything works with ARP, with IPv4. So you must be aware of these nasty things. Like here in this example, you have 3 routers connected, and they speak BGP with each other. Please don't forget root servers at the time. Okay, no root servers. So they speak BGP with each other. And you have this monkey guy here who replies with fake ARP replies. So he claims that he has address for router 2, router 3, and router 4. And what happens? All packets go to him. BGP session goes down, everything stops. Okay, you find this guy, you shut down the port, and everything goes back to normal again. But what if you use root servers? What happens then? Okay, here the same situation, but you have a root server here. So these only peer, they don't peer with each other. They only have BGP with root servers. Okay, so packets, BGP sessions are only established with the root server. And okay, again, this funny guy came, and everything goes down, traffic stops, and again, you find the guy, you shut down the port. And you think it will go to normal. Will it? No. Because they don't speak with each other. No packets are sent from this router to this one. So they don't recover the ARP table. Never. Okay, they recover the ARP table after it expired. But normally, for those who know Cisco equipment or some other, it can take hours for ARP cache to expire. So in this case, traffic can be black holed for hours, just because of this some incident here. So be aware of ARP. ARP can be a killer. Okay? I don't want to scare you. Okay? It never happened in our case. But I'm just pointing out that this is one thing you must know. Yeah? ARP is the basic. And for IPv6 also, you have IPv6 neighbor discovery, but this is the other story. There are some software tools that can help you with this. So if your internet exchange is growing, you might consider to implement something that is called ARP Spawns. I don't know why they call it Spawns really. It kind of, because maybe it cleans the ARP caches like a sponge, you know. Huh? Yeah, it sucks. Like yeah, yeah, like sucks it up. Yeah. So this is a piece of software that can help you to improve sanity on the internet. Okay. You will find more details at this fine presentation here. You can search it on the Google. You will find it easily. It's ARP hijacking mitigation. It was presented in EuroX forum. So EuroX forum is also fine for technical presentation, obviously. And please go to and read it. It's good presentation. It's nice, really nice. And take your time and okay. Ja, dvije muve jednim udarcem. Je to prava riječ? Ok, to moj srpski slab, ali to je to. Drugo, about next hop self, tuđe nećemo. For example, this one pairs with this one, this mentor, but he dislikes this guy here. He doesn't want to have BGP peering with him. He doesn't want any traffic from him. That's why I call it tuđe nećemo. What do you think? So the traffic from R3 to R1, R2 should go like this, always. Not directly to him. Yes? What will happen if you don't do anything on the configuration? You know about BGP a little bit. So next hop for this network will be what? A or B? B? Even if it is announced from router 2? Yeah, that's correct. We have definition here. Thank you. That's correct answer. So the address will be B. The next hop will be B because this is an exception in BGP in broadcast domain. Yeah, same network. So it will be B, and you don't want that. So please configure net hop self also for external BGP. Next hop self is the clue. So if this one configures net hop self, the traffic will go to him. Ali svoje ne damo. If the traffic goes to him and then he returns the traffic on the same interface that it received it, what will happen? It will send a redirect message. So first packet will go to him, and he will send, don't send this to me, send directly to him, and we'll send a redirect message. So please disable the redirect messages. Talking a lot, but just 2 lines. I'm talking for a few minutes about just 2 config lines. So
that's not the spirit of internet exchange.
Yes, because the Air 1 has nothing to do with Air 3 or Air 2.
it's about policy. They don't like each other, you know.
But
Okay,
what
hopefully
does
it is
do
not the
with
spirit
Air
of
1?
internet exchange. You're right.
So remember, we're live streaming, so if you want to ask a question, we'll need Matjaž to repeat it so people who are listening from outside this room and other countries, because Georgia's tuning in and
Yes,
Macedonia
yes.
and the US are actually
So I
listening.
repeat this
Yeah.
observation.
Yeah.
This is not the spirit of internet exchange, but it's a technical issue, and you might keep this in mind. It's different if you use root servers, but here maybe it's politics something. So Jan, can you please repeat what?
So R2 needs to talk to Air 1, and R3 needs to talk to Air 1, and both need to tell them that they don't like each other. What is this to do anything with Air 1? That's a different company.
Yeah, it's a different company, but R1 should accept the traffic that was sent to him and not redirect it to somebody else, because this guy here doesn't want this traffic. Maybe even he has filters, and these filters will block that kind of traffic.
So how
So
do you
no
deal with
redirect.
this? So how do you deal with the fact if Air 1 does all that and does not disable all this?
How do you deal with the fact if R1 doesn't obey the rules? Yeah, okay. No, does that, okay. You talk with them. You talk with them. Why are you doing this? I mean, we are an internet exchange. Please don't do that. That's maybe one of the answers. Okay. Unreachables. If you disable unreachable messages, you might break path empty discovery for IPv4. For example, you have big packet coming in and small pipe going out. If you disable a reachable message here, path empty discovery will fail. So please don't touch unreachables. Let them on. This is only for IPv4. For IPv6, other messages are used. So for IPv6, this is not an issue. So to combine all these things in Cisco language, you will find something like this. You know, no proxy ARP, no redirects, no vendor proprietary protocols like CDP, you name it. No broadcasts, no IPv6 router advertisements. Keep ICMP unreachables there. And that's kind of an example of configuration. So just a little bit of sanity on a member port. That this is a port on your router that you connect to the internet exchange. Next topic. If you have multiple locations, example 2 locations, you don't want, you have member A present on both locations and member B. When they talk to each other, you want the traffic to stay on the same location. You don't want to use this interconnection because this is kind of expensive link all around Serbia. But this is on the same location. So you want to use these internal links. So you must take care of it. For example, if you have 40G or something, this is graph from 6. This is the traffic that from the whole, both of locations. Only a few G goes between one location and another. It should be 0 or almost 0, but it is not because some of the guys do not announce everything on one location on the other location. So some prefixes are missing, so the traffic goes a little bit from one location to another. But it should be somewhere close to 0. It happened, then somebody, wise guy configured something, then it goes up and it goes down. So reduce this to a minimum if possible. About locations, a little bit more technical. You have 2 members, 1 member present at 2 locations. So they have 2 routers, one at this kind of a red location and the other on the blue location. And 10 minutes. And you want this traffic to go like that, not from one location to another. What will you do? What can you do? One solution is that you use BGP communities. You mark in prefixes like this one with the blue location community, in the other with red location, and so this one can prefer these routes from the red location, and he will send this traffic to this router, not to the other one. This is one of the options to use BGP communities. Remember, we don't have root servers here. So in Cisco IIS, you might configure something like that. I will skip this because it's just for your reference. Just an example of Cisco language. For bad, if you send the traffic to another location, you increase metric for this route, so it's not as good as the local location. Also in Junos, something like that. Just a few examples to show you. About BGP. I only have 10 minutes. Can I take maybe a few minutes more? If you're interested in this stuff. Otherwise, I can.
You're standing between lunch and.
Lunch, yeah.
No, there's another panel.
Yeah, that will be a problem. Okay, so I will just give you
another panel than lunch.
Okay, about BGP. BGP is a kind of a policy. Yeah, more than a routing protocol. It's all about policy. And it has to be secured. So you have to filter all the announcements. You have to have some sanity checks, like don't announce a default route to Internet Exchange, or don't announce full routing table to those guys. Okay? And if somebody makes a mistake, please don't accept everything. So you have
MD passwords here?
We do. We do suggest to use MD5 authentication. You
We do
also?
it, yeah.
We strongly recommend it, but some members don't do it. You have really good drafts here. These two drafts are great. So please read them. It's really well written and good quality. So we use MDP, oh yeah. So do not accept your own roots. So when, I don't know here. This is a kind of sanity check when you receive roots. Limit, this is one is important. Limit the number of the accepted roots. Somebody can make a mistake and they will announce your full routing table. You don't want your router to crash because of it. So limit the number, limit to some decent number, maybe 1,000 roots or 100 total. And MD5 authentication. You asked Jan before. This is to authenticate the session. Other stuff here. And always, this is najboljima. Beware of the default route. You will find somebody that will announce your default route sooner or later.
At least 5 times in our network.
At least 5 times. Okay, you winner. We have this 3 or 2 times at 6. So filter that out. A little bit more. And at Internet Exchange, you sometimes do not want to accept more specific prefixes. You have to decide what is the most specific network prefix that you will accept. In Slovenia, we decided to go to /24, not 25 for IPv4, and for IPv6, we do not accept any more specific than /48. What about Serbian Internet Exchange? Something similar?
For IPv4, it's 24.
24, even more strict? Yeah.
And for V6, probably 14.
Yeah. So for Serbia and Serbian Internet Exchange, they decided to go to /24. So you are even more strict than we do.
Some usual suspects that announce 25 and we can't move them away from that.
A comment here from gentlemen in the first row. There are some usual suspects that keep on announcing small prefixes, and we can't get rid of them.
Yeah.
So that's why we decided to make. We can get rid of them, but they are friendly. So we decided to go through /24, 25. Important thing. Please do register your prefixes in the right database. Here you have an example how you can check all the prefixes to root objects that Arnes has, Academic and Research Network of Slovenia. So you hear all the mess we have. All of them should be registered in RIPE database. This is a must. Vesna.
Tomorrow I will show a tool that shows the consistency between the routing registry and the actual BGP routing in the RIPE stat.
Oh, great.
So that will connect with your.
So to repeat a little bit for the recording, Vesna will show tomorrow a tool that will display the consistency. They will make the consistency check between what is written in RIPE database and what is actually announced on routers. Okay, something like that. So register your objects. You have some examples here. How can you check what is registered, which IS numbers are behind somebody, like Arnes in this case. So there are public servers, and you can query them, and you will get responses like commercialized internet providers like Level 3. They have their server. You can ask them using whois. Just an example how to use these tools, Register, we've seen this before. Bijal was talking about it. It is a screenshot for peering DB. It is we encourage you to enter your data in this peering DB. So in peering DB, you have all the information that is needed. You have the addresses. You have also the geographic location of the data center, things like that. Please register your information in the peering DB. And Vesna probably will talk about this, maybe RPKI.
I'll just mention it so you can go on.
Okay, I will also just mention it. this is the technology that you can use to validate a prefix you receive, that this guy is really authorized to announce it. So this particular AS. So you don't receive, I don't know, prefix for Google from Afghanistan. And RIPE has a really nice tool for doing this. It is web-based and it's really easy to use. And it's also implemented on all new routers, like Juniper, MX, Sirius, like the new routers have it. And also the Cisco software has support for this. So if you receive the root, you can check, you can validate the root in a local cache if this root is really supposed to be announced from a certain AS. It can be valid, it can be invalid, or unknown. It's up to you what will you do with that root. If it's invalid, you might drop it, or don't want to route toward that destination. About goodies now. So when I'm with the time?
You have about 5 more minutes.
5 more minutes. So fast. Big yes for root servers. Use root servers from the day one. If you have 2 members, you use root servers. Tomorrow you will have 3 members, 4, 5, 17. Root servers is a must. There is a nice tool. Nick Hillard will present probably this tool to you, probably tomorrow. It's called IXP Manager. So this is a really nice tool. You can use it as a portal to what you...
This afternoon.
This afternoon?
Yeah.
Great.
Provided he makes it.
So IXP Manager is one option for you. Harald will show you another great tool they wrote by themselves at Aconet. Also great piece of software. If you have time, or please provide looking glass for the members, so the members can check what others are announcing, and also graphs, fancy graphs, you know. It is always a dilemma whether these graphs should be open for public or not. Kind of in Slovenia, we were kind of afraid to open this. You know, you have some guys that are not pleased if they see full links, and on the other side, there are guys that are not pleased with they see empty links. So it's up to you if you make them public or not. About root servers, we use BIRD, Slovenian Internet Exchange. I won't tell you how it works because of the lack of the time, but please come to me after the presentation. I will show you in detail how this actually works. Okay, and Harald will speak more about it. They also use BIRD at the Vienna Internet Exchange, am I right? Yes, and
did you switch from Quagga to BIRD?
We never used.
It was BIRD from the beginning.
We started. It wasn't from the beginning in 1994. It just we use it now for 2 years now. But I strongly encourage you to use from the beginning, from day one. Root server actually here, we will discuss this later, but it is all about policy. Root server can help you with filtering the announcements. It can go to the RIPE database and check for all the prefixes that are registered there and can filter for you. So you don't have to bother. So it improves security, actually. So that's why I'm strongly suggesting that you're using this. And on the other hand, if the Internet Exchange is big, you don't need full BGP mesh between the members. If you have 10 members, you have, without root server, you will have 10 times 45 BGP sessions there instead of 10. So that's one of the reasons to use root servers. Okay, and skipping this, sorry. So improved, it enforces the security. It can filter, it can block Martian roots like those 10 something, 192, like private prefixes. It can block a default root for you. It can block more specifics. It can do everything. Just, it's cool. But remember, it's up to you. And you are responsible for the security of your network. So it's still up to you. You can use root server, but still be responsible on your side. I have more examples, but I will skip them. You can use also root server. You can use also BGP communities to control which roots are announced to somebody. Maybe you dislike member X and you don't want that your roots are announced to member X, so you can use BGP communities to do that with the root server, etc., etc. And about localization, I will skip. IXP Manager will be presented later on. Nice tool. We still run the first version of IXP Manager. They now, I think they have version 3 or something, so we need to upgrade. But even the first version is great. I mean, you have all the information about the members, you have the information on which switch are connected, which ports, what is the speed of the port, AS number. You can have fancy graphs here, statistics, you will show all the graphs for you. There is also place for documentation, so you have some like presentations like this one today, you can put it here and the members can always find it there. Don't want to look for in the internet for them. Everything you have here. And one thing, this thing actually prepares the configuration for your root server. So if you're using Bird, this piece of software prepares all the config files for you. So you can use this configuration for root server. Great stuff. Looking glass. This example is from one looking glass. We don't have a looking glass on 6 yet. We kind of behind with implementation of looking glass. Do you have a looking glass on Serbian?
Not yet.
No? Looking glass is great. You can every member can check for every route what is there. How they can make ping trace route. So this is good option for an internet exchange, like a goodie, as I said before. And of course, at least if you don't have a looking glass, you can have a special router. We call it root collector. This is a special router that pairs with the root server or with each other, with every member. And you give access to your members to this particular router, and they can type their show commands, whatever they want. You give them read access, obviously not to read and write, so they can only look. But this is a kind of a poor man's looking glass, I would say. So you can find an old router, instead of throwing it away, you can connect it to your internet exchange and use it. Okay? Graphs are always fancy, but not only the traffic. Traffic is important for maybe managers and but not for technicians. There are other things that are important. Maybe number of packets, maybe number of errors. If errors occur, graph them. And maybe the level of optical receive power on the port. These are things that are important. If you have a graph like this, you can see that the optical power is kind of a stable. So this is, for example, from Telecom Slovenia link. If you see something like going down, that's bad. So not only traffic. Please graph as much as you can. Collect everything you can. You don't need to look at that, okay? But just collect the data. You might need it afterwards. And one of the most important thing about internet exchanges, I think, is to meet the community. Like today. So meet the community. So this event is great. We'll have a cake, not tomorrow. Maybe next year we will celebrate in 20 years. So if we meet next year, I'll bring a cake. I promise. And that's all for me. Thank you.
Bravo.
Thank you for inviting me once again. So for all the technical details, please come to me afterwards.
No questions?
Well,
If there are any questions, please.
we have a panel next.
Just
So.
one quick question on the
Yeah.
graphs.
Yeah.
Isn't it fine to provide the aggregated statistics
Yeah.
and not the individualized service provider traffic? Is there any problem with that?
That the question was about the graphs. Is it okay to provide only aggregated statistics and not the individual? Yes, in some cases you will go for that. You will only publicly provide the aggregated statistic, which if you also export to URX. Am I right, Vijay? So you also take these statistics from aggregate statistics and it can be shown at your portal?
Yeah, that's right.
The aggregate one? So this
yeah.
is publicly available?
It's publicly available, yeah. On the URX website.
And the other thing is for individual members, we typically go for this solution that each member can see each other traffics, but it is not publicly available. So at Slovenian Internet Exchange, you can't see publicly all the individual graphs, but only the members can check for each other. And they can speculate, okay, I announced this, aha, here it is.
The thing to remember is the traffic on the port for individual members is commercially sensitive.
Yeah, it's commercially sensitive.
People that are on the exchange
Yeah.
so,
And if it goes down, everybody will be finger pointed. Look at the telecom Slovenia is down, and you know, it's a bad thing to do. You don't do that. So maybe it's better to keep this internal inside of the community. Between friends, that's all Internet Exchange is about, yeah? Between friends.
Yeah.
Sorry, Vijay.
Yeah, no, I just wanted to say that that's exactly how it works. Is that you know, we don't monitor the traffic. Well, IXPs generally don't monitor the traffic for the individual ports, but it's aggregated. And actually, something else that I should mention, which is on the slides. But I don't think I actually said it out loud, was that when you were looking at the traffic graphs, those graphs were actually on traffic that is reported on the public peering LAN. So there are a lot of exchanges that do private interconnects, and that's not what was shown on the graphs that I showed earlier. So the graphs that I showed earlier is the aggregated traffic on the public peering LANs, which is available not only on the Internet Exchange websites, but as I showed you, also on the URX website.
Yeah, thank you, Vijay. So obviously we are hungry.
Well, there's
No,
a
no,
panel.
there is another panel.
There's a panel.
Ah, there's a panel.
And you're on it.
Oh, okay.